Hi, my name is Denis Angell. I work for XRPL Labs, and today we're going to be learning about Xahau and JS hooks. We're going to learn how to run a standalone environment. We're going to build the hooks, and then we're going to deploy those hooks to the standalone environment. The first thing I want to discuss is some of the differences with the Xahau sidechain. The first one is called balance rewards. This allows a user to earn a balance adjustment on their Xah holdings. It's 4% per year. The second transaction is the import transactor, which allows you to burn IOU tokens on the XRPL ledger and then mint them on the Xahau sidechain. You can do the same thing with non-fungible tokens. So you can burn a non-fungible token and mint a URI token on the sidechain. Another feature is our NF token standard, which is URI tokens. Some of the key components here are that it's a top-level directory lookup, so we don't have to iterate through pages. The URI token object also includes an owner and an issuer. Another key feature is IOU for escrow and payment channels. So you can you can escrow your IOU token on the Xahau sidechain. And then finally, we have a remit transactor, which allows you to send up to 32 IOU payments and also include the ability to mint a URI token to that destination, and as well as send URI tokens with that transactor. So it's sort of like a batch payment transaction. So we're going to start to dive into hooks. I'll explain what hooks are. Hooks are smart contracts for XRPL ledger protocols. Smart contracts are compiled bytecode deployed to the blockchain, and then the blockchain comes to a consensus, and then transactions are then executed against that. Hooks are a little different in that in normal smart contracts, you initiate a transaction to trigger the smart contract. With hooks, the smart contract actually is sort of hooked onto each transactor in the XRPL. And so if I make a payment to you and you have a hook on your account, then that smart contract code runs. There's 4 different types or ways to interact with the smart contract. You can create the smart contract. You can install an existing smart contract that somebody else has built. You can update your smart contract. This is something that the EVM doesn't really allow, but we do. And then you can obviously delete that smart contract. The big thing that sort of I discussed, which is called hook on, and that's basically when you upload your smart contract, you're going to tell the system which transactions that smart contract will execute on. So if you wanted to execute on payments or escrow or only payments, etc. So it really allows for a high level of customability. Another feature when you want to execute a smart contract, so you send a payment to someone who has a smart contract on their account, you can include parameters or arguments. So you can, when you call that smart contract, you can include arguments so that you can retrieve that in the smart contract and execute business logic based on those parameters. Another thing in smart contracts that's really important is state, being able to store data and retrieve data inside of that smart contract. So Xahau does allow you to create a state inside of the smart contract. You can create up to 256 bytes, and then you retrieve that data using functions that we have provided. Another big feature to smart contracts is the ability to manipulate data. Using Xahau and hooks, we do that a little bit differently. What we do is we emit transactions. So if I had a smart contract running somewhere, I could invoke that smart contract, and then that smart contract could then emit a payment, and that payment could go to somebody else. So you can emit different types, all the different types of core protocol transactions that XRPL has. You can emit those from inside of a smart contract. So that's basically an overview of how hooks work or smart contracts on Xahau. And so now we're going to go into building those hooks.
In this tutorial, we're going to be compiling, building, and deploying hooks in JavaScript on the Xahau JavaScript hooks testnet. So the first thing you need to do is you go to Riplet and you will clone or fork the correct repository. So when you go to Riplet, you'll come here and type in my name, Denis Angell, hit search, go to people, click on my name here, click on the JS Hooks Toolkit standalone, and then you'll want to fork that. And when you fork that, you should end up with something like this. So the first thing we're going to do is we're going to add a new shell. So click on the new tab, scroll all the way down to shell, click that one. We need to add 2 of them. So click here, scroll all the way down, shell. In our first shell, we're going to run the standalone environment. That is /start. And then you can tab over and it should autofill it. And then we'll hit enter and run that. What that should do is open up the web view, and then it should say here, publishing ledger 2. This is an explorer, so we can view transactions on the ledger, and you can actually close the ledger like so. So you can see it on the left, there's ledger 3, and then you can click on ledger 3 and you can see the information and the transactions and the total coins. So that is a sort of running the standalone. The standalone is a local build of the blockchain without the consensus mechanism. So you can automatically validate transactions like so. It's very helpful for testing. We can write tests, and then we can shut it down and we can start it back up again, and then it starts back at ledger 3, ledger 4. So it's really helpful when you need a specifically defined environment, and then when you need to run a test against something where the variables don't change, right? So if you send a balance to someone, now the balance has changed and you can't really test that. So that's why I like to use it. You don't have to, but for this tutorial, we're going to be using it. So now we're going to build the hook. First, we're going to go over what is in the hook. I'm going to slide that over to the right. So under under contracts base TS, we're going to see the JavaScript hook. As we paid attention to the documentation, we know that all hooks start with a hook constructor. Here we're going to be tracing out some information, just some text information. We're going to get OTXN. When we see this, stands for originating transaction. So again, in hooks, it's hooked on everything. So there's always going to be an originating transaction. And so we're going to define that as an invoke transaction. Then we have our transaction here. And what we can do then is we can trace out the transaction JSON, and we can trace out the account. So we can deconstruct the object and then get that account variable, and maybe we want to check that against something. Maybe we want to check the amount on a payment, the destination on an escrow cancel, anything like that. So we're just going to show how to sort of trace those variables out, and then back in our source file, we have sort of a main setup. So we set up our test context. This test context using setup client creates an environment for us that has a number of different accounts. So 10 different accounts that are funded, 5 different hook accounts that are funded, and then those 10 accounts, Alice, Bob, Carol, Dave, they all get an issued currency from a gateway account. So it's just super helpful, so you can hit the ground running. You don't need to initialize those accounts. When you run setup client, it will make sure those accounts are initialized. Here we're going to add a hook parameter. We're going to see this later. This is our create hook payload. This builds the hook, the single hook, and then we put that hook in a hook chain. And then this is our set hooks v3 transaction. This will set the hook on this hook 1 account. And then we want to invoke it, and that's when that's when the actual hook is going to run. So part of it's setting the hook, or in Ethereum, deploying the hook. And then this is interacting with the hook or invoking the hook. So we did the same thing. We have a originating transaction parameter that we're going to look at later, but here is our transaction, the invoke transaction. We have an account from Alice. The destination is the hook wallet. We add that hook parameter to the transaction, and then this is our submit function. And then we pull out some of the executions just to validate and view the hook executions as we discuss. So back to our README, it's npm run build, and this should, npm run build base. So now we're going to run. Now that built. So now we're going to we're going to build the hook. So that's npm run build base. This one's the base transaction. So this is going to call an API to a central server, send the hook and build it, and that built, and we have a hook hash as a response. And then in our build folder, we can see the build BC file. Now we are going to interact with the blockchain, and we are going to install our hooks. So now we're going to do npm run base, and this is going to set our hook and invoke it. So what we should see here is a lot of transactions coming across. Good. Those are all the funding accounts. Okay. And now we can take a look at our most recent 2 transactions. So on ledger 82, this is going to be the set hook transaction. So here we can see our hook. This is what the create hook payload made. We can see it was successful. And then here we can see our invoke transaction. And we can see our hook parameter on there. And we can come down here and we can see hook executions. And this tells us that a hook, this hook in particular on this hook account, was invoked. And the instruction count was 0, and the result was 3. And the hook string, which is probably one of the more important parts, the return code or the return string, is a hex variable. And if we take that, we copy it, we go up here to our hex encoder decoder, we can go from hex and we can see base TS finished. So we can go over here back to our hook, our base hook, and we can see that base TS finished was the accept result. So this is the return string, and this is the return code, as we see here. Now, if we take a look at our this is our debug string. This is listening on our Xahau node. We can actually get some information here. So we traced out some information. So we can see base TS called. That's up here. So we can see that the hook, this is when the hook was invoked. So it was called. And then we can see the OTX JSON. This is the JSON that invoked the hook. So we can see it was a invoke transaction. We can see the account and the destination and the fee. So we can see the whole entire transaction, even the signature. And then what we did is we deconstructed the account out of that. And there it is. So now we can see that, we can pull whatever JSON invokes the hook, we can pull all these variables out and do with whatever we want. So lots of different options there. So now what we're going to do is we're going to take a look at hook parameters. So let's uncomment that code, and basically that's going to get the hook parameter out of the a hook parameter is when you set the hook. An OTXM parameter is on the transaction. So in this case, it was set on the hook, and this is just a helper function to pull it out of the hook. And then on our hook, we'll go back up and we'll see that what we're going to send in is a JSON object ID number 1. Now we need to rebuild our hook. So we'll do npm run build base. That built successfully, and now we can do npm run base again. And if we go over here back to our debug string, we can now see on top of the OTXN JSON we have a hook parameter, and that's the JSON data. And then if we deconstruct the ID, then we have 1. So now we can see we could, when we set a hook and hook parameters, as I mentioned earlier, but I'll repeat again, hook parameters, when you set them on a hook, they're always there on the hook, no matter who invokes it. So you could, sort of like a constructor argument. So you could add a constructor argument with some information here and do with that with whatever you like. Maybe your use case calls for some constructor arguments. We'll show one a little later where we use the constructive argument in an actual use case. So now we're going to go back to base, and we're gonna check out the OTXM parameters. So we're going to do the same thing. We're going to uncomment the code. We're going to go back to our shell. We're going to build it, and then we're going to run it. And then we're going to go back to our shell, and we can see here now we also have the OTXM parameter. So we have the hook parameter still and the OTXM parameter, and that value is 2 on the ID. And if just to double check, we go back so we can see that's our hook parameter and that's our transaction parameter. So we did not, we didn't update the hook parameter. That was automatically on there. What we were able to do was pass in a specific argument on the transaction. So that might also be helpful for you. Okay. So finally, let's adjust state, and let's look at a state variable. So here what we're going to do is we're going to get the state for a counter. If that counter state doesn't exist, if we've never updated that before, then we're going to reset the counter to 0. And if there was a value, then we're going to turn that value from a hex into a 64 using these helper functions. And then we're going to trace out the counter before, and then we're going to add 1 to the counter, and then we're going to reset that counter in state. And then we're going to trace out the new counter value. So we'll just uncomment that and press save. Go back to our shell, build the hook, run it, and now we should see some state variables, some counter logs. So, yep, so we can see our counter was 0, and then it was 1, which is what we wanted now, which is exactly, so the counter should have been 0 because it didn't exist, and then it added 1, and then it logged it out. Now let's just run that again, and we should get 1 and then 2. Boom, 1 and 2. And so state allows you to store any type of variable. In this case, we're storing numbers, but you could store any type of variable in the hook state. And so then you can access in your hooks, in your smart contracts, you can access state variables. This is extremely helpful. This is probably one of the main core features about creating business logic, is the ability to store a variable and then later read that variable and do something based on that variable. So that is the example of base. Now we're going to look at the example of redirect. So the redirect hook, what it does is starts the same. We just, trace out that it was called, just so we know. We get the OTX and JSON. In this case, we're going to be sending a payment in. In this case, we're going to be sending a payment in. We're going to get the amount. We're also going to get a hook parameter as an account, and we're going to call that forward address. Whenever we emit a transaction, we have to do an ETXN reserve. The hook needs to know how many emitted transaction will occur. If you don't have this, it will fail. So then we build our transaction, our payment. We take our amount and we want to take 90% of this and forward it on. So it's a redirect hook. So a payment is going to come in, and then 90% of it is going to go somewhere else, and we're going to hold 10%. So that's what this line does. We have our forward address, which is as a hex variable, and so we're going to turn that hex into a utility. So that's what that line does. The next line, the destination, we pull our forward address from the hook parameter, and we're going to convert that to an R address from the hook parameter hex value, and then put that in as the destination. So when we create our hook, that's who we're telling is the forward address. So instead of each transaction specifying who to forward it to, it's specified by the hook, by the owner. So sort of a control mechanism. And then finally, the account on the transaction is, in this case, the destination of the originating transaction, right? That might get a little confusing. There's another couple ways you can get the hook account from the hook itself, but in this case, whenever a hook is invoked, which hook. In this case, which hook was invoked because it's the destination of a payment. It could be different for your use case, though. So another way I would read up in the documentation is by using the hook account variable. So now we have our built transaction. We want to use the prepare function. This is going to add the fees, the signing public key, the last ledger sequence, the first ledger sequence, etc. Just pretty much gets your transaction prepared and ready to go. We're going to log that out. Then we're going to emit the transaction, which is going to return a transaction hash. And if that hash is greater than 0, then the transaction was successful. If the hash is a negative number, then that's an error code, and we could log that. In this case, we're just going to roll back. So that's the redirect hook. Now we can go and we can see what our code's going to do. So here we have our hook parameter ACC. We take Carol is who we're going to redirect the amount to. And we're going to take that address, Carol's classic address, and we're going to take it and we're going to hex it. And this is just a helper function, XRP address to hex. So we convert it to a hex. It needs to be converted specifically using this function, or you would get a bad variable inside the hook. So then we create our hook payload, and in this case, it's going to hook on payment. We add our hook parameters. We set our hook as per usual, and then here's our payment, and we make our payment from Alice to the hook wallet in the amount of 1 drop. So that's that. So now we're going to do npm run build redirect, and that built. And so now we're going to do npm run redirect. And that transaction was emitted successfully. So now let's take a look at what happened here. So we have our set hook transaction. Then we have our payment that went in for 1 XRP or ZA. And then we scroll down and now we can see another field. Now we have hook emissions. So this is an emitted transaction, and you can actually click on this emitted transaction ID and you can see the emitted result. And so here now we can see that's 90% of the original value was emitted to this destination, and you can just see this is some emit details so that we know that the transaction was an emitted transaction, and you can see it was successful in the delivered amount. And what we can do is we can also go back to our debug stream and we can see some of the things here. So we can see the going from the bottom to the top, we can see the TX hash here, and here is our prepared payment. So we only added the amount, the account, the amount, and the destination, and it added the rest of the details. So the emit details, the fee, the first ledger sequence, the last ledger sequence, the sequence, etc. So it added all that. So it's a nice helper function to get that going. So that is emitting a transaction. You know, another big key part of smart contracts, which is affecting other ledger entries, affecting other things in the system.
So now that we've compiled the smart contract, we're going to go ahead and deploy it to the blockchain, and then we're going to invoke that smart contract and get the console log that we just explained. So we run npm run test, and now here we can see that the contract is deployed through this transaction, and then the next transaction here, now we can see that an invoke transaction was made, and then if we go to our debug stream over here, we can actually see that trace log information. So we can see the transaction that occurred, we can see the incoming transaction parameters, and that is sort of, I guess, the basic level steps. From here, we can edit our smart contract to do whatever sort of business logic functions we want to do. We can go into some more advanced use cases, etc. That's pretty much where we'll end.
So that's it for today. But if you found this interesting or you enjoyed it, please like and follow. Thank you very much. I appreciate your time, and I will talk to you soon.